A very good afternoon to all of you. Today I am here to present my topic on overview of network security. So, first of all we will start with what is the network security. Network security means security over the internet. When the file is transferred over the network from one sender to the receiver, we said our file should be transferred securely. To send the file securely, we should have to maintain these four standards. The very first is confidentiality. Confidentiality means only sender and the intended receiver should be understand the message content. Means no other person, no any unauthorized person or other than the intended receiver and the sender, only they are the persons who can understand the message. For this you can encrypt the message and the receiver can decrypt the message so that no other person can understand the message to have the intended validity of the message. The second is authentication. Authentication means only authorized person, only valid person can understand the message. The sender and the receiver want to confirm identity of each other. Sender want to confirm that the receiver is valid and the receiver want to confirm that the sender is valid. Then comes to the message that have message integrity. Integrity means validity. The sender and the receiver who want to ensure message not altered or transit or afterward without detection during the transmission, means whatever the sender has sent, only that message is received by the receiver. The message is not tampered, not damaged, not changed during the transmission over the network. And the fourth is access and availability. The service must be accessible and available to the user, means whatever you are want to transfer over the network, that services, that things should be accessible. Accessible means they can be in the reach of the users and they are available to the user. So the security means confidentiality, only the intended receiver and sender can read the message. Valid message is spread, valid persons can read the message, and the message should be accessible and available to the user. This is the one of the example. Suppose who are our friends and who are the enemies over the network. I am taking one example. There are two persons, the one is Neil and the other is Nikki, and there is a one Trudy person in between the network. Neil and Nikki are the two friends actually who want to communicate over the network. But there is a Trudy, one instructor who is not an authorized man. He not want that Neil and Nikki do any of valid communication. So Neil and Nikki are lovers. They want to communicate securely. But what the intruder can do? He can intercept the message, he can delete the message, he can add more messages to each other what they are communicating, but they actually do not want to be. So our security is over the internet to eliminate such intruders, such persons, such unauthorized persons who damages the message, who can change the message, delete the message over the network. So we want a secure message communication over the network. This is the what security needs. Who might the Neil Nikki be in the real life? Who can be the Neil and Nikki? This is the one of the example that Neil and Nikki are the two persons, but over the network, who are the communication? Communication is done between the web browsers, servers for electronic transactions, online applications, online banking, client servers, DNS servers, router exchanging routing table updates, and the many more examples in the real time, that everything is on the net, everything is done online, either communication, either banking, either either you are doing any shopping, we are doing all of things over the network. So over the network, the banks are the Neil and Nikki, customers are the Neil and Nikki, browsers are the Neil and Nikki, servers are the Neil and Nikki, who are actually communicating, and we want to secure these datas. But out of these, who are the bad guys or bad girls as well, say, on the network? So here are some examples what these bad guys or interactor or hacker are doing over the network. The first is eavesdropping. Eavesdropping is nothing but the intercept message, actively insert into the messages into connection. Means they are secretly adding the messages, what the actual messages, they secretly adding the fake messages over the network. Then comes the impersonation. That means can fake spoof source address in the packet or any field in the packet. Impersonation means secretly hiding and sending the fake messages upon your address by using your identity, sending their messages. Then comes the hijacking. Hijacking is nothing but the takeover of the ongoing connection by removing senders or receiver, inserting himself in a place. Either they remove the sender or the receiver and inserting himself onto the network, and they communicating with the other. And the last is denial of service. Denial of service means to prevent service from being used by other. We are using the service, but we are denying that we are not using the server. This is also can be done by the bad guys. So these are some network security threats which can happen by these bad guys who are actually controlling the network without your permission. The very first is packet sniffing. Packet sniffing is nothing. Suppose here A and the B want to they are communicating with each other, but this C is an intruder. This is an intruder who is acting as B and started communication with A. So this is known as the packet sniffing. This packet sniffing can be done in the broadcast media. This promiscuous NIC reads all the packet passing by. So whatever the B is sending to A, all the messages are read by C, and C inserted their own messages and that are sent to the A. So C sniffs B's packet. This C sniffs the B's packet and sending to the A. This is known as the packet sniffing. There are some countermeasures that we can take to stop this packet sniffing. What we can do, all hosts in the organization run software that checks periodically if host interface in promiscuous mode. And the other way is one host per segment of broadcast media. That means on a one Ethernet or at a one hub, we can allow only a limited number of the user, so that no the unauthorized users can access your network. If they people are accessing, then we should know, it can be known to us that two persons are communicating, the one is actual and the other is intruder. The next is denial of service. This is the one of the threat. Denial of service means intruder is sending flood of messages to the A, so that A can be confused that which is the correct message and which is not. So this is a denial of service is flood of maliciously generated packets, that is the swamp messages that are received by the receiver. So distributed denial of service means multiple coordinate sources swamp receiver. So here C and the remote host synchronously attack A. C is attacking on A by sending multiple flood of messages to the A on the behalf of B. So here are some countermeasures that can be taken to stop the denial of service. The very first is filter out. Filter out means flooded packet before reaching host throughout good with bad. Means we can synchronized that only some of the messages can be received by the A. So when the flood of messages come, then it can be detected by A that there is some intruder who is sitting in between A and B. The second is trace back, means by maintaining the log. When you are maintaining the log of anything, then you can know that something is going wrong and you can easily detect that thing. So trace back to the source of flood, most like an innocent and the compromised machine. Then comes the cryptography. This is the cryptography is the one of the technique to stop the any unauthorized access on the network. So first of all, the definition of cryptography is it is a art of secret writing of code so that no any unauthorized person can read it. Whatever we are sending on the network, we are encoded the data into some secret language so that no any unauthorized person can understand what the message is. So this cryptography technique helps to maintain this confidentiality. This confidentiality means only sender or the intended receiver should understand the message content. What it means? It means when the sender sending the message to the receiver, it encrypts the message. It means it encode the message into some other language which cannot be understandable and or understand by the user at the other side. And when the message is received by the receiver, it is decrypted by. Decryption means to convert the secret writing to the human understandable or we say that receiver understandable language. Sender encode the message and the receiver decode the message. The whole process is known as cryptography, and this cryptography helps to maintain the confidentiality. The next is endpoint authentication. Endpoint authentication means who are actually receiving the message is an authorized person. Sender, receiver want to confirm identity of each other. So this is the endpoint authentication. Only authorized person who have the actual privilege to read the message, to write the message, to update the message are receiving the message. So this is endpoint authentication. Then comes the message integrity. Message integrity means validity of message. Only the sender and receiver want to ensure the message during the transmission over the network, the message is not altered or it is not transit or afterwards without detection. Now these are the crypto system services, means what the cryptography services can be giving to us. The very first is what obvious is confidentiality, that is only the intended sender and receiver is sending the message and receiving the message. Integrity means only the valid message is transferred over the network, that is valid over the time, valid over the authenticity and authorization. Only the privileges are given, then the message is sent by the sender and receiver. So integrity means validity and consistency. Next is authenticity. Authenticity is the authorization of the person, sender and receiver, who are actually sending the messages and receiving the messages are the valid person. No repetition. No repetition means no repetition of the message. Next come the access control. Access control means those persons who are sending the message have the privilege to send the message, and who is receiving the message have the privilege to receive the message, means they have the authorities to send and receive the message. They can access, they should have control. Only those people are actually doing the communication. Next come the types of cryptography. The cryptography can be stream-based cipher. Cipher is nothing but the secret code which is transferred over the network. When using the cryptographic algorithm, we transfer the simple text to encoded system. We said it is a cipher text, and this stream-based cipher is one at a time, please. When you converted or applying any algorithm on one message, that should be for the one time, means that key is generated for one time, so that the intruder or unauthorized persons cannot understand the message integrity. It also include mixes the plain text with key stream. For example, after every 2 bytes you inserted any key, so that any known unauthorized person cannot understand your message. Then comes the good for real time services, means these should be time based, so that out of the time, or you can say when the time is over, the message will not be reached to the person. Then comes the block ciphers. Block ciphers means you choose a key in the form of blocks, like a block of 2 bits, 4 bits, 5 bits, etc., and you substitute that key and transport the message over the network. You substitute the key into the original message and send the message over the network. Then this encryption system includes substitution ciphers, as I say, substituting the key, and key can be any random number or any number that is generated to intercept into the original message, so that that message cannot be understandable to the unauthorized person over the network. So it can convert one letter to another using the crypto quip. Then comes the transposition cipher. In this way, we can changing the positions of the text, like we can change the position of first alphabet with the second alphabet, second with the first. In the same way, we are changing the position of third alphabet with fourth, and fourth with the third. So this is also known as the word jumble, in which transposition is done, so that this if key algorithm is not known to the intruder person, then this message can be securely received by the receiver. Then comes the monoalphabetic cipher. This monoalphabetic cipher means when the content is actually replaced, when the alphabets are replaced by the numbers and the numbers are replaced by the alphabets, we said it is monoalphabet cipher. Now, what are the requirements to do the cryptography? Two requirements for secure use of symmetric encryption is a strong encryption algorithm, means one of the algorithm through which we can convert your message into the cipher text, and the secret key on the behalf known only to the sender and the receiver. Mathematically, we need a y is equal to EKX, that is the any encryption algorithm, and X is here is the key to decrypt the algorithm at the receiver side. So assume encryption algorithm is known E, and D refers to the implies a secure channel to distribute key. Now comes the private key cryptography. Traditionally, private, secret or single. We can say anything, like we can say private, we can say secret, we can say single. Actually, traditionally, a secret key is used to encrypt the message. It is shared by both the sender and the receiver. If this key is disclosed, communications are compromised. Compromised means they can be tampered by any unauthorized access. This is also known as symmetric key, or parties are equal, hence does not protect sender from receiver for giving the message and claiming it is sent by the sender. So, in the public key, the one key is set by both the sender and receiver. They are both sharing the same key and they both have to remember the key during the communication. If either of party forget the key, they should not compromise or they should not protect sender from receiving or claiming the message that is sent by the sender. Then key, the public key cryptography. Public key means, as the name suggests, this is the key which is known to all. Probably most significance advance in the 3-year history of cryptography. This public key cryptography is used for sending the large amount of data. When we have to send the large amount of data to the many of the users, we actually use the public key cryptography, and when we have to send the small amount of data to the limited users, then we use the private key cryptography. In the same way, this public key cryptography uses the two keys. The one is known as public key and the other is private key. Public key is a key which is known to all and the private key is the key which is the only known to the individual person. Only one person is knowing about the private key and the public key is known to all. So, asymmetric cryptography, since parties are not equal, because one having, it is the asymmetric cryptography because one party have the public key and the one party have the private key. Useless clever application of number theoretical concepts to function. This public key cryptography complements rather than replaces private key crypto. Then comes the why public key cryptography. Because it is developed by address of two key issues. The one is key distribution, means that key is used to encrypt the message. Key is nothing but a unique code or a unique message that have to distribute all so that they can encrypt the message and decrypt the message. Encryption is nothing but the secret writing of code. So, how to have secure communication in journal without having to trust a KDC with your keys. So, so key distribution means when we have to spread the key to multiple of the persons and said that it is a key through which you can access the message. Next come the digital signature. Digital signature is also one of a way to verify a message comes intact from a claimed sender or not. So, public invention due to Duffy and Hellman at Stanford University in 1976, known earlier in the classified community. The public key cryptography having the two keys. When we are using two keys, we said it is a asymmetric cryptography. When we using the same key for both the sender and the receiver, we said it is a symmetric key cryptography. In the asymmetric cryptography, a public key is used which may be known by anybody and can be used to encrypt messages and verify signatures. And a private key is known only to the recipients, used to decrypt messages and create signatures. So, public key is known to anybody and they can use it to encrypt the message and verify signature. And the private key is known only to the recipients, used to decrypt messages and sign the signature. The public key cryptography is asymmetric because those who encrypt the message or verify signatures cannot decrypt the message or create signatures. This is how the public key cryptography is done. Here you see this is the plain text which you have to transfer to the sender. This is the plain text. When you encrypt this message using any algorithm, means you are locking the message in some container type, a box type, you are using the algorithm which is the technique of encryption. You encrypt you use the encryption algorithm, for example RSA, and using the public key. Public key, it is known to Joy, it is known to Mike, it is known to Alice, it is known to Ted, means it is known to anybody. Now this is Bob's public key. He is encrypting the message. This is the key who is used to open this. So when you encrypt the message using the public key, this message is transferred over the network, and then this message is known as cipher text. When this cipher text is received at the receiver side using this alias private key, that is the receiver's private key is used to open up this box, or you can say decryption algorithm, reverse of encryption algorithm is applying on this, and then this plain text is received by the receiver. Since over the network this data is secured by encryption algorithm and the decryption algorithm, so no any unauthorized person or intruder person cannot understand this message. Now the characteristics of public key are: public key algorithm rely on two keys where it is computationally infeasible to find decryption key knowing only algorithms and encryption key. It is the computationally easy to encrypt or decrypt the messages when the relevant encrypt and the decrypt key is known. Either of the two related keys can be used for encryption, which on the other hand the decryption for the same algorithm. When it is known as the public key is known to all, and either both are using the public key or only the sender using the public key to encrypt or decrypt the message. This is how public key cryptographic system. Here is a message, this is a source A, this is the encryption algorithm. Encryption algorithm is applying on the message X and then converted it to Y. Again the encryption algorithm is applying on it by using the sender's key. This is known as the public key encryption. When the and this message is get, when at the receiver side this key pair is used to decrypt the message using the decryption algorithm, and then this message is find out. So this double key is used. This key pair public key is used to encrypt the message, and the pair of public key and the private key is used to decrypt the message. This is how the public key works. Now the applications of the public key this can be classified into three categories. The one is obviously the basic function is encryption and the decryption. Other is digital signature. Digital signatures are used, these provide the authentication of the persons or the user. The final is key exchange, means a session key. Session means one session is going on when we are doing any communication between sender and receiver. The time when the communication is start and the time when the communication end, the whole time is known as one session, and key is generated to encrypt the message and to decrypt the message. So encryption, decryption, authentication using the digital signature, and the key exchange by the session key are the three of the application of public key cryptography. Now the security issues over the public key schemes. Like private key schemes, this brute force exhaustive search attack is always theoretically possible. Brute force means multiple access until you not succeed, but this is a time consuming process. Both key use are too large, that is it is more than 512 bits. Securely relies on large enough difference in difficulty between easy. Securely relies on large enough difference, but it is also a difficult method. Most generally the hard problem is known, but it is made hard enough to be impractical to break. It required the use of very large number. To generate the key we should require a very large number, hence it is slow as compared to the private key scheme. Now the symmetric encryption is on conventional. Symmetric means same when the sender and the receiver using the same key, we said it is a symmetric encryption or a conventional encryption. Sender and the receiver share the common key. All classical encryption algorithms are the private key. Was only prior to the invention of public key in 1970, and it is most widely used as today. This is how symmetric cipher model. Here you see this is a plain text. This is when we using the DES algorithm.